All right then. So I think the first and foremost important aspect is how do you interact with the Kubernetes cluster. A few words about the question, where do you get a Kubernetes cluster from? There are various sources for getting Kubernetes clusters these days. All the major infrastructure providers have an offering. For example, Amazon, Google Cloud, Ali Cloud, Microsoft Azure. As Any9s, we also have a product about this, which is Any9s Kubernetes, which you can take in your private data center as part of the Any9s platform, where there's Cloud Foundry, Kubernetes, and a collection of data servers with full lifecycle automation. There's a version online where you can create an account and go through the tutorial. For the final exam, we're still figuring out which how we're going to provide access to you as the students. If you're an external subscriber to this training, you can always go to parsany9s.com and get your own instance, or use any other Kubernetes cluster. At some point, for example, where the Ingress, in the Ingress chapter, you may have to figure out yourself how to do it, because Ingress configuration can be provider specific. Beside of that, most of the general topics will work for any Kubernetes distribution. In particular, I'd like to point to Minikube. There's a way to set up Kubernetes clusters on your local computer, and it will also be good enough for doing most of the parts covered in the training. I personally use macOS with Homebrew, so brew, install Minikube, and there you go. Obviously, that will start a virtual machine with all the pods and Kubernetes system inside of that virtual machine, and therefore you'll have to give it a certain amount of resources. So in my particular case, I gave it 10 gigabytes of memory, which is quite a lot, but this is already good enough to even try out distributed application deployments, as we'll do it in the final exam. Could also be that we'll give you a live cluster for doing that, so that you'll have a experience with a remote cluster that is closer to a staging or production environment, just to get the feeling what you would be doing in a real world scenario. But I'm saying, if you want to play with it right away, Minikube is a good way to start. All right. Time to open a terminal. So I have configured a Kubernetes cluster so far. So you can see that there's a Kubernetes master running at this particular IP address and this port. The API is reachable via HTTPS. There's also a DNS system. Then this is what you get when using the kubectl cluster info command. Now this is interesting because often you'll be interacting with multiple Kubernetes clusters. For example, sometimes I will use the Minikube cluster locally because I don't want to break my remote cluster or deploy something that could potentially interfere with other workloads, especially if you're deploying changes to the Kubernetes or add-ons to the Kubernetes cluster itself. This may happen. So it is quite natural that you'll change your Kubernetes cluster from time to time. So this is done by setting your kubeconfig environment variable. So if you point that to a different config file, you'll be setting the kubectl to interact with the different Kubernetes cluster. Also, you'll have to understand that Kubernetes is a fast-moving target in the sense that there are continuously new versions being released. So keeping track of the version of the cluster that you interact with is very important, especially if you follow tutorials. It is necessary that you'll figure out, first of all, your client, your Kubernetes, your kubectl client should be up to date. And the way you find out what the versions of your local kubectl client and your remote server is kubectl version. So the client version here is 1.18 and the server version is also 1.18, which will be good enough for our tutorial. Now, if you happen to use an older version of Kubernetes, it may happen that resources are named different, that particular features aren't present. I mean, it's kind of common sense, but if you're into like looking into a tutorial that's a bit older, that refers to an older Kubernetes version, you may be using annotations or API versions that don't work with your particular version, or you might be missing using a concept that has been introduced in your clusters. For example, stateful sets have been introduced, I think, in Kubernetes 1.15. Not particularly sure about that version, but this example is meant to tell you, if you go back, use an old version, you might be missing structures that are meaningful and helpful. So try to get a decent kubectl and Kubernetes version. All right. So now we know that how to figure out which version we are using. We've found out what is the endpoint of our cluster. It's also possible to get a proxy to your Kubernetes cluster, because by default the Kubernetes cluster is something that that runs in a remote data center somewhere. If you deploy something, let's say a pod, and the pod opens a port, it is not reachable from the outside until you create a service and an ingress. And if you wanna reach out to a pod before creating an ingress, then you can use the kubectl proxy command to get a reverse proxy to your local computer and talk to your local host on that particular port, which will then give you the impression as if you were inside the Kubernetes cluster. This is very handy, especially during the development of the provisioning structure. So let's say you've written in a distributed application system, and you now have to describe it in Kubernetes. So pretty much what you will be doing in the final exam. In this case, you will have to make small steps. Find out, how do I describe my stateless application? Well, I know I should be using a deployment. Well, then how do I describe the replica set inside that? What is the pod definition going to look like? How many replicas do I want? So until you figure out how exactly this works, you might be doing from time to time a bit of debugging, and looking at the immediate results can be very easy when using the kubectl proxy. It could be the case that if you're using different flavors of Kubernetes, that the kubectl proxy command need to be parameterized in order to get it working. But the general syntax for creating such a proxy is that one in the tutorial. So let me open the command kubectl proxy. This will create a local will open a local port, and let me see whether I can curl that. So here you go. So I've created, I've started the kubectl proxy, which will now listen on port 8001. I'm using curl. Curl, for those who've not been using command lines on a Unix or Linux-based system. Curl is like a little web browser, so I can use curl to issue post requests, arbitrary HTTP requests, and get a feedback on the console. So if you're scripting, for example, using web services, then curl will be very, very handy. So in this case, curling the localhost on port 8001, you can see that it will provide you with the endpoints of the Kubernetes cluster available in the API. So I could also use my browser to do that. Now here's the same result.